Hello guys, so in this video we are going to discuss the solution of a problem isomorphic string. So let us go through the problem statement. So the problem says that we are given two strings as string 1 and string 2. Check if these two strings are isomorphic to each other. So now let us see what is an isomorphic string. So the two strings are isomorphic if the character is string 1 can be changed to get string 2, then two string str1 and str2 are isomorphic. A character must be completely swapped out for another character. While maintaining the order of the characters, a character may map to itself but no other. So this is what the isomorphic string is. So let me explain this. So an isomorphic string is basically, let us say we are given two string s1 and s2 is given to us, and let us say s1 is a b and s2 is x and y. So now in this particular string, if we replace, so in s1, if we replace all occurrences of a by x and all occurrences of b by y, then s1 can be transformed to s2, right? So for instance, s1 is a b, and let us transform it, so this becomes xxy, which is s2. Similarly, in s2 string, if I replace all occurrences of x by a and all occurrences of y by b, then s2 can be transformed into s1, right? So for instance, s2 is basically xxy, and let us replace all occurrences of x by a and all occurrences of y by b, then this can be transformed into s1. So if s1 can be transformed into s2 by performing this operation, and s2 can be transformed into s1 by performing this operation, then we will say that s1 and s2 are isomorphic string. Okay, so that is the definition of isomorphic string. There is one example which, let me discuss that example, which is a special case, or which is a corner case for this problem, which has to be considered while coding. So let us do that. So let us say s1 corresponds to a b, and s2 corresponds to x y, and let's say there is c also there, and this is x, right? So now here, if we replace all occurrence, so here if you see, a and x has a relationship, b and y has a relationship, and c and x has a relationship. So a from s1 to s2 we are seeing, so a has a relationship with x, b has a relationship with y, and c has a relationship with x, right? When we talk about the relationship between s2 to s1, we see that x has a relationship with a, y has a relationship with b, and x again has a relationship with c. So look at these two. So from here we can say that x has a relationship between a and c, and this, when this happens, so basically there has to be a one-to-one relationship between s1 and s2, all characters of s1 to s2, right? And similarly from s2 to s1. So if there exists such a case where x belongs to more than one character, then in such cases s1 and s2 are not an isomorphic string. Okay, so this is the peculiar case I was talking about, and while designing a solution for this, we should be aware of this. Okay, so now let us discuss the solution for this problem. So I will be giving two solutions for it. So let me give solution 1, and then we will discuss solution 2 also. The solution 1 will so in solution 1, let's discuss solution 1. So let us say the string is a b, and let me use the same this. So this is c, whereas s2 is basically x y and x, right? So the way we are going to do it is basically we will iterate on S1. While iterating on S1, what we are going to do is basically, so we are going to iterate on S1. So initially we are here, okay, and we will say, and while doing so we will maintain a dictionary, okay. So we'll keep maintaining a dictionary, and we'll check whether A's entry is there in the dictionary or not. So initially the dictionary is empty, so A's entry is not there. So now we are going to make an entry of A in the dictionary. And what should be its value? The value will be the corresponding value in S2 string. So A corresponds to X. So that mapping we were talking about, A corresponds to X and B corresponds to Y and so on, is something which we will maintain in our dictionary. Okay. Now so we'll make an entry in it. A corresponds to X in our dictionary. What it simply means is that any occurrences of A, if we see in string S1, then it must corresponds to X in string S2. That's all it meant. And that is why we are maintaining it in our dictionary. So again, we move to this. We see that this is also A and X, and A is already there, and it also corresponds to X, so we are okay. So for the cases, let us say if there is, here rather than X, it would have been some other value, right? Let's say Y. Then in such cases, we were expecting it to correspond to X, but here it is Y. So in such cases, we will return false. We will state that it's not an isomorphic string. Okay. Again, moving forward, we will check if B. So we saw it here, it is B, and B is not there in our dictionary. So we will make an entry of B and Y, and we will move forward. Again, we saw C is not in our dictionary, and we will move forward. Okay. So by the end of this, we will maintain this dictionary. So by the end of iterating on S1, we will form this dictionary. And if at all by iterating S1, if S1 cannot be transformed into S2, then at such cases we would have returned false. So I'm talking about this particular case where A, let us say if it corresponds to Y. So in that, while iterating in that portion itself, we would have returned false. Okay. So this is, that is how we'll iterate on S1, and we will return true or false. Similarly, we will do the same thing on S2, and we will maintain dictionary and so on, and we will return true or false. Okay. So for instance, in dictionary, when we are iterating on S2, we'll maintain a dictionary. So initially X is A. Again, we saw X is A, and that is okay with us. Then we saw Y is B, which is also fine. Then again we saw X, and this time X corresponds to C, right? So now X corresponds to C, but we are expecting it to correspond to A, because of which we will return false. Okay, right. And if after iteration of S1 and S2 we did not return false, then in such cases we will return true. Okay. So that's about solution 1. But as you can see, in solution 1 we are iterating on S1, and then we are iterating on S2, right? So two pass is needed here in solution 1. Now we will look into solution 2, wherein we will be able to do the same thing with just one pass. Okay, so this is solution 2, and let us see how we can do it in just one pass. So let me take S1, which is A, B, and let's say this is C, and this is S2, this is X, Y, and X. Okay, so let us see how we are going to do it. So again, we are going to maintain a dictionary. So a dictionary will be needed, and the dictionary will contain the same thing, which is A corresponds to X or A corresponds to Y, whatever. The same thing which we were doing it solution 1, the same thing we will do it here. Apart from dictionary, we will also use another dictionary, which is, let us call it a used dictionary, which just gives us this information that whether we have consumed that character or not. So let me explain what do I mean by this. So initially I am here. Again, A's entry, so this time we will just iterate on S1. Okay, so initially we are at here, so initially we are at this position, and we saw that A is entry of A is not there in the dictionary, so we are going to make an entry of A in our dictionary, and this corresponds to X. Okay, so now we saw that X is so A corresponds to X entry, we made it in a dictionary, and what we are going to do is that we will say that X has already been used. So that is what we are using use dictionary for. Okay, next time again we go into A, and we saw that A's entry is already there. Okay, so since A's entry is already there, then it must corresponds to X, and it is corresponding to X, so we are okay there, and we will proceed forward. This time we will see B, and B's entry is Y, so we'll make an entry of B into Y, and Y we will say it as true. Okay, so that's fine. So far we are here. Then we will come to C. So we'll say that C's entry is not here, and we will go ahead and make an entry in here. While making this entry, we will also check whether I have used this or not, right? And whether I have used this or not is something which is maintained in X in this dictionary. So we will see that this has already been used here. Since this has already been used here, so we can go ahead and return false for this case. Okay. So I hope the explanation was, you are able to follow the explanation. Now let us look at the code, how we are going to code this. So I have already coded it. So like I said, that we'll be using two dictionaries, dictionary and used. And this is one more case which is obvious, like if the length of string 1 and string 2 differs, then that simply means that string S1 and string S2 are not isomorphic. So in such cases we'll return false. Now otherwise, if the lengths are equal, then we are going to iterate on S1 or string 1, and we will check whether str1 of I is there in our dictionary or not. If it is not there in our dictionary, so we are going to make an entry of it. Before making an entry, we will check whether str2 has already been consumed or not. If it has already been consumed, then we will return false. Otherwise, we are going to mark this as true, that we have consumed this particular letter or alphabet of string 2, and we are going to make an entry in str in the dictionary also. Otherwise, if it is already there in a dictionary, then we know that that it should corresponds to the value of the dictionary. So essentially here, let me jump to here. So if it is already there, so for instance A and X entry is already here, and next time we are seeing A, then we know that A should corresponds to X. So this X and this thing should be same. Okay, and if that is not the case, then we are going to return false. If after iteration we did not return false, that means that it is an isomorphic string, and we can go ahead and return true. Okay, so that's about the coding part. Now let us submit the solution. So our code got accepted, folks. So that's about from this video, folks. If you have any queries or question regarding this video, please feel free to drop it in a comment, and I'll try to address them. Thank you.